In Android, all the visual elements that make up a screen are views, and they're all children of the view class. They share a lot of properties. For example, all views have a width and a height and a background, and they all can be made interactive. Examples of views you have already seen are text view for holding text, image view, and buttons. Other views are edit text for entering and changing text. And we have checkboxes, sliders, menus, color pickers, and many, many more that you will meet in later lessons. Or you can look them up in the documentation. And if none of the many, many provided views meet your needs, you can even implement your own custom views. So, every view has a location expressed as a pair of left and top coordinates and two dimensions, a width and a height. The unit for expressing location and dimensions is the density-independent pixel, pronounced dp or dip. dp is an abstract unit that is based on the physical pixel density of the screen. For example, 1 dp is 1 pixel on a 160 dots per inch screen, but 3 pixels on a 480 dots per inch screen. So the cool thing about dp is that Android devices will automatically handle the conversion from dp to pixel values. Developers just have to use dp values to specify measurements in layouts. Views that make up a layout are organized as a hierarchy of views. Views whose primary job it is to contain other views are called view groups. Commonly, a layout has a top-level view group and any number of views and view groups inside it. Linear layout is a view group where you can arrange views horizontally or vertically. When you define a linear layout, you set its orientation to horizontal or vertical, and then add views to it. Because the About Me app has a simple vertical layout, we will use linear layout. Another view group is for scrollable content. It's scroll view, and we'll use that too. There are dozens of other layouts. Now, the views in our layout are inflated to create a hierarchy of view objects. When Android system creates and draws this view hierarchy, it is traversed, sometimes multiple times, to calculate where every view needs to go, taking into account each view's size, location, how views might overlap, and additional constraints. For some apps, this view hierarchy can get pretty complex. The deeper the view hierarchy is, the more work the Android system has to do to calculate layouts. While the Android system optimizes this process, having big, deep view hierarchies can eventually affect performance. The app may load slowly and respond poorly to users. To help with this, Android offers a layout that promotes a flat view hierarchy and is optimized for laying out its views. It's constrained layout. And in fact, you can build any design using a constrained layout. So why would you even bother with other layouts then? Well, it's about trade-offs. Constrained layout is best for arranging a small number of views or view groups in a complex layout that might otherwise require deep nesting. All right, let's go build About Me.